1 plus 0.05 divided by, I don't have n, so I have to fictitiously use x, but that's okay, it's the same thing. Don't forget the caret for the power, and in parentheses, it may take it without parentheses, but I'm a math professor, I love my parentheses. Of course, 4x. At this point, if you do not have go to second and table set, and make sure that just the independent variable is in the ask mode. Only the independent. So if it is, if it isn't, just scroll down and highlight ask and then press enter. So in my case, I already have this done. Then I go to second and table, and I enter exactly what you just gave me. You gave me 1, you gave me 2, you gave me 4, you gave me 365, and you gave me 365, and the calculator will do this times 24 hours a day. I have to go back up. I have to go to the right. I have to highlight each and every number, and then I will write down my answers. A of 1. A of 1 is 1215.51. A of 2. 1218.40. A of 4. 1219.89. A of 365. 365, okay, that is 1221.39. And the last one, A of 8,760, that is 1221.40. That's all I wanted to record here. I want to stop recording and stop sharing. Okay. So of course, we always write the measurement unit. So this is very important. I don't want anyone to lose any points on any test. I'm going to write it now. Measurement units, comma, please, at all times. Measurement units have to be presented. If it's dollars, if it's whatever else. Okay? So this is what I recommend. If you don't enter the function as I entered it in the calculator, then you will have to punch this in 5 times. What's the point? We have the calculator. We created a function. This is the only thing that changes. And I went, after I entered the function, I went through the process. Any questions? Is this clear?
No.
Which part? Which part is not?
I think it's more the like why. Like I get the what, but not really the why, I guess.
So the problem is asking us if we invest $1,000 today at 5% per year for 4 years, and the interest is compounded once. After 4 years, how much money we have?
Okay.
If the interest is compounded twice a year for the next 4 years at 0.05, how much money we have at the end of the 4 years if it's compounded twice a year?
Okay.
Is that better?
A little. It's just going to take some practice for me.
So that's all. It's just a calculation of how much money we get after 4 years if this scenario happens. If we invest 1,000 at this interest rate per year for 4 years. And the interest is calculated, recalculated, compounded this number of times. Everything okay?
Yes.
Okay, moving on, I'd like to continue with R.2. And in R.2, I'm looking at the time, I have 10 minutes. So in 10 minutes, I just would like to talk about a topic that you discussed in college algebra. something called the difference quotient. This will help us for several chapters, in several chapters that will follow R. What is the difference quotient? Before we look at the difference quotient, let's discuss the average rate of change of a function, between point 1 and point 2. Well, point 1, if this is the function, let's say this is point 1, and let's say this is point 2. What is the average rate of change of this function between these points? Well, all I have to do is just draw a straight line between these points. And what it means is the slope of this line. The slope of this line is the average rate of change. This is nothing new. You've done this many times before, I'm sure. Okay, but how do I determine the slope? Can anyone refresh our memory if we have 2 points? So if I have point 1, let's say x1 comma f of x1, and I have point 2, which is x2 comma f of x2. How do I find the slope of the line passing through this point? With this is x1, and of course this is f of x1, and this is x2, and this is f of x2. Can anyone refresh our memory on how to determine the slope of a line passing through the 2 points?
Isn't it like x2 minus x1 over y2 minus y1?
Careful, let's write this. Rise. When we talk about rise, we talk about altitude. Over run, we talk about position. So then how do we write it? I think I haven't heard Brianna.
Sorry, could you repeat that again?
Yes. How, for the moment, I have 2 points, x1 f of x1 and x2 f of x2, and I want to write rise over run, the slope of the line passing through these points.
You would put y over x. So for the first one, like f of x over 1 over x over x1.
So careful. The rise means this difference, which is f of x2 minus f of x1.
Oh, right, sorry.
No worries. And this is the position, and they have to be the same. So what do I write in the denominator?
x2 minus x1.
Very good. So the rise is the difference between the y values over the difference between the x values, and they have to come from the same point. You cannot reverse these. These two come from point 2, these two come from point 1. Yes, so this is the average rate of change. But how do I get from the average rate of change to the difference quotient? Well, in the same way. So let's say I have a function. Let's say I have the first point, which is x. What would be the y value? If this is 5, how do I get the y value? Anyone?
Can you ask the question again?
Yes. If I have x, if I have 5, how do I get the y value? If this is 5 or 10 or x, doesn't matter. How do I get the y value?
You would get fx1 divided by 5.
No. For x1, I get f of x1. For x2, I get f of x2.
Oh, then it would be f5.
Exactly. So this will be f of 5 if x is 5, but since it's general, it's f of x. So this is point P. And let's choose a point Q. But point Q is here. Right here. Very, very, very close. But I zoomed in. So now they appear to be far away from each other. Okay. So this is x plus a little bit. A little bit is denoted by lowercase h. So again, Q is very close, but I zoomed in because if I don't zoom in, I won't be able to show anything. Can anyone now give us the y coordinate of Q?
Then it would be f of x plus f of q.
Careful. The number is x plus h. How do I determine the
X
y?
plus h.
Exactly.
Oh,
Exactly. So if I have x, this is f of x. If I have 15, this is f of 15. If I have 3,500, this is f of 3,500. If I have x plus h, this is f of x plus h. In the same way, we're going to draw a line passing through these 2 points, and now the difference quotient, dq, difference quotient, is the slope of this line. Can anyone now give us the slope of this line? It's the same formula. Yes?
It'll be f of x plus h minus f of x over x plus h minus x.
Brilliant. And of course, these two go away. So this is our difference quotient. That's it. This is the difference quotient. This is the formula for the difference quotient. And I'm sure you're going to ask, what is this? What are you telling me? What is this? And what is this? Well, here I'm telling you this. That if you give me 2 points, I can tell you the average rate of this function between these 2 points. But now, what does this mean? Well, if Q is very, very close here, what this means is almost. Almost. So the difference quotient. So, do I have a Chloe? I don't have a Chloe. So, let's let her in and see for a second. I don't have a Chloe. Chloe, can you hear me? Chloe? Chloe, can you hear me? Chloe, can you hear me? Hello? Are you in this class? This is Math 230. Are you in this class? Is that a yes or no? The math, that's what I thought. That's why I'm answering. So we start at 8:30. So the Zoom meeting for your class, for the intro class, or the Zoom meeting starts at 8:30. You're more than welcome to stay. This is a different class. So I know I have to stop. I just want to write what this means, and I'll stop, promise. Okay, so the difference quotient, because Q is so close here, this is almost, not exactly, the instantaneous rate of change. Of function f of x. Almost.